Okay. Hi guys, welcome. This is module cm4269, Green and Sustainable Chemistry. And this is the first lecture in the context unit. It may be that I have to chop this into more than one piece because of the size of the files, but we'll see how we go. Okay, so here is where we're going today. We're going to look at the traditional manufacturing model. We're going to think about the economics of that model, and of course the chemical industry is part of the manufacturing sector, therefore it's very relevant. And we'll look at the idea of externalities and pollution. We will then briefly think about some of the implications for our world, for industry, working in an environment. We'll close with just a summary. Okay, reading for this module. As you know, in the module booklet there is a reading list, and the recommended book for this module is Lancaster. For this particular module, in addition, I'd rather try that again, shall we? I'd recommend Garrett Harding's 1968 science paper, The Tragedy of the Commons. The references appears here, and Kerry Turner and Co. Environmental Economics and Elementary Introduction. You'll find these two references useful for today. In addition, there are other references scattered through the lecture slides. This small yellow text is how I will usually give references on this course. Okay, so let's move on. This slide you'll see probably most lectures. It's just an organisational schematic of the module, and basically allows you to keep track on where we are. I seem to have a stray T there, for which I apologise. Okay, another slide you'll see every lecture. The subject of green chemistry often gets confused with that of environmental chemistry. And as in this course, that is in chemistry at NUS, there are modules taught in all three areas, and they all occur in the energy and environment specialisation. I'd just like to clarify with you what these are and where this module and certainly this lecture fits. So we start with biogeochemistry. This is planetary-wide systems. It's how the planetary system works, the chemistry of that system. And in this module there will be next to nothing of that. An occasional mention, possibly. The next step down is environmental chemistry. Now that's looking at the detailed chemistry of reservoirs, particularly on how that chemistry impacts things that we've put in the system, pollutants if you will. Now there is some environmental chemistry in this module, not a huge amount, but nonetheless it's there. Then we get to green chemistry, which is the subject of this module. To be honest, we're not really interested, or not very fully interested, in the impact on the environment. As I say, there will be some, and we will at some parts in the course go to some of those places. But green chemistry is a rather different animal. It's about avoiding the problem entirely by designing better synthesis, better reagents, less waste, more efficient process. And this runs full square with the general industrial current, which is if you have a process making, I don't know, benzene or whatever, actually, why should you spend more resources than you need to make product of a nominal quality, whether that's analar or technical, if you can produce the same product at the same quality for less. So in industry, the idea always is you're looking at how you can improve your bottom line in the business, but in terms of the manufacturing, improve aspects of the synthesis or the purification or whatever you're doing to get either a better product or the same product at lower cost. So effectively, this is pretty much full square in the territory of industrial chemistry, and we'll talk more about that as the module moves on. This is broadly laid out in the module booklet, so I'm not going to spend any time now particularly talking about it. Okay, upward and onward. Right, so let's start at the beginning. Companies are, and the chemical industries, I'll say industries as well then, but companies are at the centre of the economy. I put up here some data really about small companies, and they're normally abbreviated to SME, small and medium-sized enterprises. And I'd like to have a little walk through this because it's interesting. First of all, I'd like us to think about the second column, the percentage of companies which are SMEs, small and medium-sized enterprises, in the US economy, the UK economy, the Singaporean economy, and the New Zealand economy. Now, clearly there's a order of magnitude difference here. The US and the UK are very large economies, whereas Singapore and New Zealand are much smaller economies. However, irrespective of the size of the economy, a massive number, 100% or so close that statistically you have to round to 100, but certainly 90% and more of companies in these economies are small companies. Now, how these jurisdictions define small varies, and it's not really very important. In the New Zealand and in the US, anything of less than 20 employees is an SME. In the UK, it's less than 50, and in Singapore, it's less than 200. But in one sense, that's accountancy, not really relevant at the moment to what we're doing. And these companies between them, what percentage of the workforce do they employ? Well, let's just take the US as an example. You've got 5.2 million of these companies, and they employ 35% of the workforce. So really not insignificant of the private sector workforce. In the UK and Singapore, it's much higher, maybe 60 or 70%. In New Zealand, it's lower, 30%. So in terms of how the economy works, these SMEs, almost in whatever jurisdiction you want to choose, are pretty much important. And in the larger economies, note, they're responsible for about half of GDP. GDP is gross domestic product, and it takes into account all of the money changing hands, all of the transactions. So if I go and buy a computer, that's a contribution to GDP. Unfortunately, if I go and crash my car, then the repair is also a contribution to GDP. But it's a measurement of economic activity. And half, just about, of all economic activity in the two larger economies on this table are down to SMEs. In Singapore and New Zealand, it's considerably less. Singapore is a bit of a special case. I'll be careful how I say this. In fact, Singapore government is very executive. and government here is large. Singapore government seem to have fingers in many pies and own all sorts of large amounts of Singapore. Therefore, those employees are not in the SMEs, they're not in the private sector, they're actually elsewhere. What that means is that because the employee pool is reduced by large government, the percentage of employees in SMEs seems larger, although the actual number isn't large. And likewise, the amount of GDP accounted for by the SMEs is quite low because a lot of the GDP is actually done by government. Okay, so SMEs important, private companies are important in keeping economies running. Let's now think about why that might be. This is a pie chart, and it happens to be the 2010 UK budget. The entire budget's about 670 billion UK pounds, which is about, I don't know, if I just do a rough exchange rate of 2 to 1, it means it's about 1,400 billion Singapore dollars. And I've put this up to show you the sorts of things that a country needs or government needs. So I just look at the headings here: transport, social services, housing, environment, debt interest, public order, defence, education, health, and it goes on and on. These are just the major budget heads, and there's a lot more fine detail there. So these are the types of things that countries need. If you like, services they have to buy. In the UK, in 2010, because they needed to buy these services, they actually needed money, and they needed about 670 billion UK pounds to deliver this annual budget. Right, so countries need to buy things, they need therefore money. Where does this money come from? Does it come from the government? Well, what do governments do? This is not a policy course, but we'll spend a moment. Governments raise taxes. Financially, governments pass laws and governments enact regulation. They do many other things, and this budget gives you an idea of the things that governments do, which you already know. But they do not actually make money. So there are a number of options as to where the government might get its money from. Now, we of course are aware of this wonderful tree, the money tree. Its Latin name is Splendiferous Sterlingus Smithsii officinalis. It's the common money tree. And we know, don't we, that all governments and large companies have one of these in their backyard. In Singapore, there are orchards of them, vast orchards near the reservoirs where they grow their money. You also, I hope, know that I am being somewhat tongue-in-cheek. Money does not grow on trees. This wonderful tree, I'm afraid, doesn't exist as far as I know. The way that governments fund their activities, the things they need to buy, actually is ultimately from industry and commerce, from companies. Where does government get its money from? Well, it taxes and charges companies and industries and commerce directly, but those companies pay you and me Joe Blogg's taxpayer, and then they tax us too. So ultimately, most of the money springs from industry and commerce. Countries, well, anyway, we'll go there a bit later. So, to continue our thinking, our sort of investigation of the how this system works, the industrial system, in fact the chemical industry it's going to be, let's do something, a very economic thing. Let's follow the money. If you're ever doing policy work or economics, follow the money is always very good advice if you're trying to untangle a story. So let's look at a very general manufacturing model. It's general because it doesn't particularly apply to the chemical industry. You could be making cars, you could be making cookies, Christmas cards, you name it. So, to set up a successful business, you need all of these components. So you need non-material resources, knowledge, information. I'll ask you an obvious question. Education in this and many other, well, any other country, I think, is reasonably valued, and so universities are set up because they are a source of these non-material resources, information, knowledge, know-how. You need a source of finance because you're hopefully going to be making money, but actually you're going to be spending money. You need material resources. That includes not only your ingredients that you're putting in to make your product, but actually you're going to need them to actually make the place where you're going to make things, the factory or however. You're going to need people, and obviously the people, some of the people have the know-how, some of the people have the knowledge, and it's a group undertaking making anything. And last but not least, you need outputs, some product, something you're going to sell, goods or services. Because if you don't have any of these, then, well, you'll spend a lot of money getting this set up, but you'll not bring any money in, and the outlook for your company is not good. So, if you've got all of this, materials, people, knowledge, know-how, facility, finance, and outputs, then you have a business. Okay, so you've got your functional company, and for our purposes it can be anything you like. We'll think of it as a cookie company at the moment. And for that company to continue, that is to be sustainable in economic terms, certain things have to happen. When you have got all of your operations sorted, so you know what cookies you're making, you've got the recipes, you've costed it up per cookie, you've remembered that actually you need electricity and gas and services, you've got to pay the rates on your factory, you've got to pay salaries, in fact there's a whole load of things. We'll look at those costs in a moment. When you've got all of that sorted and you go out and sell your cookies, so your outputs are sold and everybody loves them, and you'll get a bundle of money from your total sales. Now, this sort of is obvious. If your total costs exactly equal your total sales, your company is going under. Effectively, your price or your profit must be greater than, sorry, I'll try that again. Basically, your total sales must be greater than your total costs. And in fact, just slightly greater is not usually enough either to keep your company going. Okay, how is this relevant? Well, to a chemical company it's relevant, but it's also relevant to countries. Your price for any of your cookies, in this case, will be equal to the costs, all the costs of making your cookie, plus an element of profit. And that profit can then be invested back in to make more cookies or a bigger factory or make something else or whatever. It gives your company the potential to grow. Now, countries are sort of exactly like companies. There are slight differences, but pretty much. Singapore actually is a very good example of that. So basically the diagram here for a company would be, we wouldn't call it profit, we call it surplus for a country. Your surplus equals your total costs of all of your providing the services and things that you need to. Your total sales, you're a country, not a company, would be your total income, which are mostly taxes, levies, and things like that. If for a country you're not making profit, or more properly, you are not in surplus, then that becomes a real problem for your country when you're dealing with other countries. Because if people see that effectively your outgoings are greater than your incomings, the expression is you are in deficit, then people will start not wanting to take your money because your currency is actually an IOU. I don't have any banknotes on me, but certainly on most banknotes you'll find, think of the UK one, the governor of the Bank of England writes on every banknote, I promise to pay the bearer, blot, blot, blot. So your banknote is actually an IOU on your government. If your country is not in profit, if it's in loss, consistently, then there's nothing to convince other countries that your currency is actually worth anything. And so what you get is currency devaluation, you get inflation and things like that. So it's real in that sense. Okay, let's move on. What I'd like to do now is we've thought a little bit about about a very general model, and basically your profit equals your sales minus your costs. Let's have a look at costs, and we're going to spend a couple of slides on this. And first of all, cost is not the same as price. We'll do a bit more of this in a while. Okay, let's stay with our cookie company that we're all in it together. I know, NUS Chemistry Cookies. And let's think about the type of costs we might have. Well, we would have the sort of costs that are to do with how many cookies we're going to make, how much flour, how much butter, how many eggs, blah blah blah. They are called material costs. Then you've got actually the energy to cook them. Maybe using gas, maybe we're using electric, but we'll need to buy it. Now, if we're not cooking any cookies, then we don't have any material costs, it's zero. No energy inputs, it's zero. And if we've borrowed the recipe from somebody else and we've got to pay them royalties, if we make no cookies, we don't owe them anything. So in that scenario, our costs are zero. but forgive me for pointing out the obvious, so too will be your profits. So effectively, these costs, which are directly related to how many or how much of a product you make, are called variable costs because they vary with how much you're doing. There are other costs which are called fixed costs, which you have to pay whether you make 0 cookies or 1,000,000 cookies. Now these are typically maintaining your factory, the people you pay to keep all your machines ready to go, and supervision, management, insurance, rates on your property, overheads, ... So these are called fixed costs. Now a couple of them are to do with the amount of money that you've got invested in your factory. You don't go out to a green field and rub your head and make a wish over an appropriate holy book and your factory materializes in front of you. You have to build it. You have to spend money. And once you've built it, you then have to fill it with the equipment, or if we're making cookies, I suppose ovens and mixers that you would need to make your cookies. Now, those types of costs are capital costs. Now, for them, whether you make cookies all the time or you make no cookies, in terms of running a business, let's imagine you make no cookies at all, and providing you've got all your maintenance people, in 5 years' time all your equipment will be shiny, sprinkly new because you've never used it. So it's reasonable to think, okay, well, that's, I can use this equipment now for a certain period of time. If on the other hand, from day one you're going flat out making 500,000 cookies a day and hopefully selling them and making lots of profit, after 2 or 3, 4, 5 years, actually your equipment is going to be in, even if it's well maintained, it will be worn. It will be worn out. So good and sustainable business dictates that you plumb in a replacement period for your equipment. Now that's called a write-off period, and this is this depreciation is based on a write-off period. So if I have a piece of equipment worth $1,000 and I write it off over 5 years, then each year my depreciation of that equipment will be $200. It's a bit like cars when you buy them and stuff. So the important thing here is variable costs vary with the amount produced. Fixed costs do not vary with the amount produced. Let's move on. And now let's move on, rather than our cookie company, let's start now thinking of a chemical industry, a chemical plant, or a chemical industry. Okay, so this is a basically cost factors. The cost of manufacturing is how much it costs you to make something. These are typically the type of costs that you might have on your list for your factory or for your process, your chemical processes. And it's a bit more, you can see now there's a number of a bit more detail, there's more headers, and it refers to things that we will talk about a great deal, things like the process flow diagram, the PFD. You'll be actually designing them. But basically it's designed on a fairly good idea, a good plan of what you're doing, and this gives you an idea of the types of costs and expenses that you need to think about when calculating total costs. I will think about one item here. I'll just click that. This is the cost breakdown for a typical general chemical product. Going back to our diagram, notice that waste treatment is one of the costs. Treatments of waste to protect the environment. We'll talk a lot about waste in the next couple of lectures. For this typical chemical product, waste is the light blue. 15% of the cost is waste. Dealing with waste. That's actually quite a big number. Okay, let's move forward. So, typically, how does a product get costed? It's okay talking about costing everything that you need to, but how does the process work? Okay, this is a diagram. It's getting older now, and it's giving you a costing chart for a product. Note not price. This is cost, and this is for cumene, and this method will get you the equivalent price that will exactly cover your cost. Remember, that still means your company's going bust. You need to make a profit. You can't just break even. And if I follow this down, I find that the total cost per ton of cumene needs to be £393,000 for them to cover costs on this plant. I actually think that's a printing error. I apologise. That should be, oh, I don't know. Yes, that should be 39,000. Okay. And that gives you some numbers there, types of, for a typical chemical plant, the type of fixed capital that you've got involved in these things. Now, looking down here, I can see a cost which is missing. Quite a large cost. I don't see anything about waste. Remember, for a general chemical product, maybe 15% is waste of your cost is waste treatment. It varies, so pharmaceuticals, the cost is much higher. We'll get to that later in the course. So, this is a, if you like, an amplification of what that 15% means, because the cost of waste is fourfold. There's damage to the environment that you have to put right. There's production losses, which is a direct cost. There's process wastes, which you then have to treat, which is more cost. And there's the public relations damage you do because you have just polluted the local river that maybe everybody bathes in during the summer and stuff like that. So waste can be very expensive. And that 15%, yeah, can be quite serious. Okay, so this is where we dip our toes slightly into a small business, and we're going to look at some microeconomics, which is about economics splits into macroeconomics, which is big picture stuff, and microeconomics. In this module, we need to do a little bit of microeconomics, and this is a company. What I'd like to do is to look first at this graph fairly carefully. So your x-axis is sales volume, how many cookies you make, how many tons of cumene you make, whatever, and the y-axis is the unit cost, how much it costs. Now, okay, so let's start with costs, which is this line. Now, this is costs from the manufacturing standpoint, all right? And it's all costs. Now, let's first see, there are two components of this total cost. One is this one, which doesn't change no matter how many tons or cookies you make, and they are fixed costs. And the other one starts, the other component of cost, if I take the total line away from the fixed cost, it moves up from the, sorry about that, it moves up from the fixed costs and increases monotonically with your production. They are the variable costs. The flour, the butter, the benzene, the whatever. And these costs are all of the cost components. They are the true costs. What that means, and we'll get to this in a moment, yes, you've paid your workers, you've paid your rates, you've bought everything, but you're not throwing something up a chimney, pushing it into the atmosphere and therefore forgetting it, because it's not cost you anything. Well, it has cost something. It's cost the planet and your local population something. So in accounting terms, if you presented costs like this which didn't include your waste costs, because that's one of your waste costs, it would not be a true cost. This diagram is about the true cost. Everything contains all elements. Okay, so now we've got, that's the cost line. Now we've got the revenues line, which starts at 0. If you don't sell anything, if you sell 0 units, you don't get any money, and then again rises. You've set a price, so the more units you sell times the price gives you your revenue. Okay, down here in this part of the graph, obviously your costs here are greater than your income, you're running in loss. Up here, your costs are lower than your income, therefore you're running in profit. And there is the magic point, which is the point at which your income matches your outgoings, or your sales revenue matches your cost. That's your break-even point. Now, I've said before that your profit at this point is 0, and to be economically sustainable, profit must be positive, and usually not here. It usually needs to be up here somewhere. So if your profit is not, if your company is not economically sustainable, if your profit is either non-existent or too small, then your operation will end, and that's it. It's going to go bust. Companies are the economy. So if that happens to too many companies, then you get issues with government financing. Anyway, okay, so I'm assuming most of you actually knew most of that before you ever walked in here. By the way, I really like this little environment economics book by Kerry Turner. Recommend it to you, actually. I tend to use it in most of my introductory economics teaching here at the university. So let's move away from, with our focus on the company and the business, and let's move our focus to the environment in which the company operates, the marketplace. We're still following the money, and we're thinking about profit. So let's first look at another graph. And again, we'll spend a moment thinking about what the axes of this graph are and what it's telling you. So here, the y-axis is profit, and the x-axis is the quantity bought and sold. So it's slightly different from the previous graph. Right, now let's actually first of all bring to bear the knowledge you already have about this graph. So I think that the market is a system to deliver goods and services to the people. It's a distribution service, effectively a distribution system. So we'll start with the goods, the supply. So this is the company, if you want. And it's really telling you that the amount of goods, of a number of goods, of tons of benzene, whatever it is that you produce, the more of that you produce, that amount determines the price at which you can sell it. Because the way this works is that it's probably down here the supplier makes 1 unit, or I don't know, 10 units. It's not worth his while to sell them. Probably there are some circumstances where that strategy can work, but basically as the quantity he makes or she makes increases, he will become more and more willing to sell. It's about covering his marginal costs of production. There is no point selling it down here if his costs of production, if that's lower than his costs of production. So his cost of production won't be down at zero. The price he needs to recoup those costs will be greater than zero, somewhere on this line. Okay, let's go to the other line, demand. So this is the customer. And you know this line very well already. If you have very, very few of some item on sale, the price will be high. If, on the other hand, there are loads and loads of them around, the price will be low and you can get more picky. Now, at some magic point, the sweet spot, if you will, if the product is bought and sold at that price, the customer's happy, they've pretty much got what they want at the price they're happy with, the supplier is happy, he has got the price that he needs to cover his costs and stuff. So it tends to be called the equilibrium point. And at that point, the market is delivering the most benefit to the most people. I should explain this word marginal. The marginal cost is the cost of the next unit. So if you're making, cookies, let's go back to cookies. If you're making cookies, and let's imagine if you make 1,000 cookies, it's all the same price. But if you make 1,001th cookie, the next cookie, the price might be different because something may have changed. There may be a cut-off point. So the marginal cost is the worst case cost for you, which is real. So marginal is used in economics like that all the time. It determines whether a company is willing to sell or not. Okay, so what about this market? The assumptions that underlie this graph, there are a number of them, and when problems happen, it's actually usually because one of these key assumptions has been breached. The assumption is that the market is comprised of a large number of people who are free to buy and free to sell, and both the buyers and sellers individually own their goods. It's not some esoteric thing. You can buy it and you can take it home and you can own it. So that's the sort of assumption. The market is also based on the assumption of complete and transparent information. I'll give you an example. If you go to the wet market to buy apples, you get to look at them. You can pick them up. I wouldn't take a bite out of it, are you? You might get in trouble, but you can look at it and compare one apple to the other apple. So you've got pretty much complete and transparent information on which to base your decision as to whether you're going to buy this apple or that apple over there. And final assumption is that your costs and prices, note the difference, that your prices are only controlled by the market, and the assumption is that your costs are therefore controlled by the market, that there are no subsidies. So they are the main assumptions that underlie a free market. This file potentially will get rather large, so I'm going to pause after the next transparency, I think. Okay, so what does the free market do and what does it not do? Providing the assumptions are met, it's the most efficient mechanism for the distribution of goods and services. It gives the cheapest prices for goods and services. It gives the most benefit to the majority, but it only delivers market outcomes. So the market's not about other things. It's just about the operation of the buying and selling process. The market does respond to interferences like subsidies, but it does so in a strictly monetary fashion, which can give you, in policy terms, perverse outcomes. An example, not actually from this module, but I might as well use it here. An example is Indonesia have had subsidies on diesel fuel for many, many years, or a number of years. With the best will in the world, they thought this will give our people access to diesel and fuels. And what it's actually done is it's resulted in probably one of those polluted countries in Southeast Asia, because there's no value attached to fuel now and it's just burnt willy-nilly. That outcome, so it's got lots of health impacts, that outcome is a perverse outcome in terms of policies. What the market does not do, it does not deliver non-market outcomes. So it's blind to environment, it's blind to social need. That's not what it's about. And I'm going to end now. The next half of this lecture will talk about some of those. Okay, thank you very much. See you in a minute. Bye-bye.